right, guys. It's taken me a while to um, send you guys information through Canvas, especially uh, video and audio. But I'm just gonna jump right to it. Here's what you want to know for next week's quiz. You want to know the steps of muscle contraction. You also want to know the parts of the nervous system and neuroglia of the nervous system, as well as images of cardiac muscle, smooth muscle, skeletal muscle, and nerve. So, as I'm going through the notes, if those topics come up, make sure to highlight them. Mm. So, first, we're going to begin with the muscular system, right? Um, Open your notes to that. Make sure to write down details, that kind of thing. So, true or false? Is muscle the most abundant tissue in the body and most adaptable? Yes, that's true, right? And then you have your classes of muscle: skeletal, cardiac, and smooth. Make sure you guys know them by location, appearance, nucleus, and control. I'm not going to go over the major functions, but one of the functions of muscle is, of course, to contract, produce heat, and stabilize joints. Now, we have general parts of muscle. You have the origin. That's one end of the muscle that attaches to something stationary like a bone. You have the insertion, the other end of a muscle that attaches to a moving part. And then the belly is the portion in between. So if I were to take a look at my bicep, one end is attached to the origin, the other end is attached to the insertion, the moving part, and the in between is the belly. True or false? Most muscles have an antagonistic counterpart. That's true. And what that means is that for every muscle that pulls a body part to you, there's another muscle that pulls it away. So, for example, your bicep pulls your forearm towards you, your tricep pulls your forearm away. That's what that means by antagonist. True or false? Muscles that work together as a group are known as synergistic muscles. This is also true. Sometimes you need more than one muscle to carry out one movement. The next portion talks about how muscles are named. They're named on their number of origins, location of the origin and insertion, and also their location. So, an example is the bicep. It's named because it has two origins, bi meaning two. Another example is the sternocleidomastoid. It's named based on its location and insertion, right? Its origin is the sternum and clavicle. Its insertion is the mastoid process. And then last is by location. An example is the temporalis muscle. It's named because that muscle is found on the temporal bone. I won't go over too much on facial muscles, but know them just in case. Now, some of the characteristics of muscle should be able to contract, right? It should be excitable, meaning that it responds to a stimulus, whether electrical or chemical. Extensibility, the ability to stretch, and elasticity, the ability to return to its original form. The next portion talks about the connective tissues covering muscle. So we have three levels when it comes to muscle. When we're talking about one muscle fiber, right, or one muscle cell, right, it is covered by a connective tissue called the endomysium. So an endomysium covers one muscle cell, aka muscle fiber. Now, when I take a handful of muscle fibers, they got to get wrapped up by a connective tissue called the perimysium. And a group of muscle fibers, right, covered by perimysium is called a fascicle. So a fascicle is a group of muscle fibers. Then, when I take a handful of fascicles, right, and wrap them up in a connective tissue called epimysium, that forms a complete muscle. So notice that level of wrapping, right? One muscle fiber has a wrapping. Then when you take a group of muscle fibers, it's called a fascicle. It has its own wrapping. And then when you take a group of fascicles, it forms a complete muscle and must be wrapped up again. Um, these connective tissues are continuous, and they help with the elasticity of muscles and also provide roots for blood vessels and nerves to enter muscle. True or false? Muscle is multinucleate and has a rich blood supply and gives off a lot of waste. This is true. Skeletal muscle is multinucleate. It has more than one nucleus per cell and has a great blood supply, gives off a lot of waste. Now, this is something that you might want to write down. The general parts of a muscle cell, aka muscle fiber. So parts of a muscle fiber, right? You have the plasma membrane, right? But in the case of a muscle cell, right, the plasma membrane is called the sarcolemma. What makes it different? What makes the muscle cell what makes the plasma membrane of a muscle cell differ from a traditional cell? Well, the muscle cell has these transverse tubules. They connect the sarcolemma to the sarcoplasmic reticulum. It relays information from the plasma membrane of the muscle cell to the sarcoplasmic reticulum of the muscle cell. Another part of the muscle cell is the sarcoplasm. That is the cytoplasm of a muscle cell. And what makes it different is that it has large stores of glycosomes and myoglobin. Glycosomes are backup forms of sugar, and myoglobin are backup forms of oxygen. Now, why is that important? We got backup forms of sugar, backup forms of oxygen to carry out cellular respiration to make ATP energy, right? So basically, muscle cells have backup forms of energy, of resources to make energy, ATP, and that's why that's important. And then the other part of a muscle cell is the sarcoplasmic reticulum, and that's a special kind of endoplasmic reticulum of a muscle cell. But what makes it different is the calcium ions. So again, the sarcoplasmic reticulum it stores calcium ions for a muscle cell. So just to sum up that part, right, a muscle cell has the same parts as a traditional cell, but those parts are enhanced. They have extra features, and you want to be aware of those extra features that makes it different, that sets it apart from a typical cell. Another thing you definitely want to write down as I'm talking is this next portion called the myofibrils, right? They extend from one end of a muscle cell to the other. And most importantly, these myofibrils are responsible for muscle contraction, right? These myofibrils are called actin and myosin. They're arranged in a way that allows muscles to specifically contract. They're arranged in repeating units called sarcomeres. Now, let's get some details about these myofibrils, actin and myosin. So, if you're looking at the table, if you're looking at these notes, the one thing I want you to remember, for actin to work, it needs calcium. For myosin to work, it needs ATP energy. So remember that. That will never steer you wrong. What are the parts of actin? There's troponin and tropomyosin. Those are parts of actin. And the thing is, when the troponin portion of actin is exposed to calcium, the tropomyosin exposes attachment sites that myosin can fit into, right? So let me say that again. What does actin need to work? It needs calcium. What does myosin need to work? ATP energy. When parts of actin are exposed to calcium, right, it'll expose attachment sites for myosin. Once that attachment site is exposed, like opening up your palm, the myosin can then fit in, and that's where contraction happens. So be aware of those details. Know the parts of actin. Uh, know what's needed for actin to work. Know what's needed for myosin to work, right? Know those little details. Arrangements of a sarcomere. So there might be just one question on this. You'll really have to look at the slide for this. But true or false, the sarcomere is the basic structural and functional unit of skeletal muscle. This is true, right? And the arrangements of the sarcomere, you have the Z line, A band, H zone, and I band. Now, for now, the only thing I want you to know is that the A band, that portion of the sarcomere, it doesn't change length during contraction. All the other parts do, right? Excitability of muscle fibers, right? This goes, here we're talking about the electrical properties of a muscle cell. So true or false, muscle fibers, like all cells, have electrical properties. This is true, right? This is how they respond to things, communicate. Most cells are polarized, meaning that they have a negative charge on the inside compared to the outside. So most cells, right, are slightly negative on the inside, have a negative charge compared to their outside. And for muscle cells, that charge difference is known as the resting membrane potential. Now, this is something you want to write down, right? The resting membrane potential. And if muscle contraction were a race, the resting membrane potential is your starting line, right? If you're in a race, what are some of the things you do at the starting line? You prepare yourself, you stretch. There's certain criteria that have to be met, right? Resting membrane potential is our starting line. Now, what are the conditions of the resting membrane potential? We have to have a high level of potassium inside the cell, a high level of sodium outside the cell, and the cell has to favor potassium more than sodium, right? So know those details. Know the conditions of the resting membrane potential. Know what has to happen at the start of the race for contraction. And what does it all mean? It means that we've set the stage. We're ready for a muscle contraction to happen. We're ready to the muscle cell is ready to receive an impulse. It's ready to receive instructions on when to contract. Now, this next table talks about the movement of those ions, the movement of the potassium and sodium. And again, what's our starting line? High level of potassium inside, high level of sodium outside, and the cell is going to favor potassium more than sodium. So at our starting line, the potassium starts moving out of the cell, right? That lets us know that things are getting ready. The race is about to get started, right? Potassium moves out, and when enough potassium moves out, right, we go to depolarization. Sodium starts going into the cell. Sodium starts rushing in. That's depolarization. We're actually running our race. The muscle is actually beginning to contract, or going into contraction, I should say. And then when our race is done, we go into repolarization, aka resetting. We got to reset the ions and put them back in their original position. So, right, all the potassium went outside, all the sodium went in. Well, if we want to have another muscle contraction, we got to restart our race. We got to go back to the starting line, meaning that we got to bring potassium in, sodium out, and the cell has to favor potassium more than sodium, right? And how is everything reset? with the sodium potassium pump. The sodium potassium pump puts all the ions back in their original places, right, to restart our race. It resets the conditions of the resting membrane potential. And like I said, guys, make sure to know that. Know the details of the start of muscle contraction. True or false, the rapid depolarization and repolarization of the cell membrane leads to the action potential, which leads to muscle contraction. That is true. And what is that really saying, right? The rapid depolarization, repolarization. It's talking about the movement of the ions. The movement of the ions, right, results in an impulse, an action potential being sent that leads to muscle contraction. So once we get these ions moving, right, that gets our race started. Now, nerve supply to muscle fibers. So this portion is talking about what causes a muscle fiber to contract, or what gives it permission to contract. And that is the motor neuron, right? A motor neuron plus muscle cell equals a motor unit. And this is something you might want to write down, right? Motor neuron plus muscle cell equals motor unit, right? So think of it as a family, right? Who directs the children? The parent. The parent tells the kids when to go clean up their room. Well, who tells a muscle cell when to contract? The motor neuron. And you could almost remember it as mother neuron. The mother neuron tells the muscle cell when to contract. And the mother neuron plus the muscle cell form a motor unit, just like a parent and a child form a family. So we have different motor units in our body, and within those motor units, the motor neuron, is telling the muscle cells when to contract. And think of it this way as well. Can a family have more than one child? Yes, right? And that parent will tell the children when to clean up their rooms. So a motor unit can have a group of muscle cells under it, but they're all being directed by the same motor neuron. That motor neuron is telling those muscle cells when to contract. Now, how many of you guys have a hard time talking to your parents, or they have a hard time understanding you? And sometimes when you talk to your parent, you have to translate. Or maybe you live in a house where it's bilingual, and you got family that speak in one language, and you respond in English. Well, imagine for a moment that the motor neuron, when it wants to speak to the muscle cell, they're speaking two different languages, right? The motor neuron is trying to tell the muscle cell when to contract, but they speak a different language. So what do? They translate. And that's where the synapse comes in. If you're looking at your notes, the synapse, also known as the neuromuscular junction, right? It translates between the motor neuron and muscle cell. You could think of the synapse as Google Translate, right? The motor neuron is speaking an electrical language. The muscle cell speaks a chemical language. How are they going to understand each other? The synapse helps to translate, and that's what the synapse does. So when the motor neuron is sending down an electrical language and an action potential, right, that electrical language reaches the synapse, and the synapse, using calcium ions, translates the electrical language into a chemical language called ACH, acetylcholine. And once the muscle cell receives that chemical language, right, then it'll contract. So in the next question, what does it mean that acetylcholine has caused the sarcolemma to become more permeable to sodium, right? Acetylcholine, right, is the chemical language that the muscle cells understand. So acetylcholine is uh, carrying the message from the motor neuron telling it to contract. And how it does that is by letting sodium in. So let me just wrap that up, right? Motor neuron and muscle cells speak two different languages. The synapse translates, right? It goes from electrical to chemical. The chemical language that the muscle cell understands is called ACH. ACH gives permission for sodium to go into the muscle cell. Remember, that movement of ions is what gets our race started, right? So without that acetylcholine, if the muscle cell doesn't get its translation, right, then contraction can't happen. We got to be sure to translate what's being said so that the muscle cell can contract. And so again, acetylcholine, it gives permission for the sodium ions to go in, and now our race, contraction, can begin. Now, some of you guys might be a bit confused, but this is the part where you want to pay attention. At the end of the notes for muscles, for muscular system, I have a table for muscle contraction, right? Now walk with me, work with me as I'm going through this, right? It's talking about the steps of muscle contraction. Now notice where it begins. It begins with the mother neuron, motor neuron, and what happens? The motor neuron sends down an impulse. It's sending an electrical message. That message gets to the neuromuscular junction, aka the synapse, and must be translated from an electrical language into a chemical language that the muscle cell can understand. How is the neuromuscular junction able to translate? It uses calcium to release acetylcholine, the chemical language that the muscle cell understands. Acetylcholine gets in touch with the sarcolemma of the muscle cell. Remember, the sarcolemma is the plasma membrane of the muscle cell. Acetylcholine, right, allows sodium into the cell, changing the resting membrane potential, changing the position of the ions. The T tubules, right, that are located on the sarcolemma, right, relays information from the sarcolemma to the sarcoplasmic reticulum. Now remember, what's important about the sarcoplasmic reticulum? It stores calcium ions. The sarcoplasmic reticulum releases calcium ions that bind to actin and exposes binding sites on actin. Myosin changes shape because of ATP and it binds to the actin. So the actin and myosin form a cross bridge and now contraction happens, right? So you want to know those little steps and details. What's released when and what. Now once contraction has happened and it's done, the last step involves the sodium-potassium pump. The sodium-potassium pump resets our race. It resets the resting membrane potential. It puts the ions back in their original place, and now we can start our race over. Now with that table, right, I want you guys to be aware of the steps of muscle contraction, the function, and the requirements at each step. What's needed, right? Again, what does actin need to work? It needs calcium. What does myosin need to work? ATP, right? And the last question, or one of the last questions says, what is the absolute refractory period? And that is when a muscle cell cannot contract unless we put the ions back in place, right? We need enough of these ions put back in place. We have to reset enough of everything before we can have another muscle contraction, because even if we get another impulse, contraction will not happen unless we first have the ions back in place. These other questions, what is myasthenia gravis? And that is when the muscle cell no longer understands acetylcholine, no longer understands the chemical language, no longer responds to it. Myasthenia gravis is an autoimmune disease. And imagine the motor neuron trying to send a message to the muscle cell, and the muscle is not getting it, right? Imagine your mother trying to reach you through text, and there's no signal. You're not able to get that message. You're not able to do as your mother told you. So if the muscle cell cannot understand acetylcholine, if it cannot understand its own chemical language, it therefore cannot contract. And this next question, how would a lack of calcium impact contraction? Well, there's several steps, but the main one is that without calcium, right, actin cannot expose the binding sites, and therefore myosin cannot form that cross bridge. Without that actin, we cannot have contraction. I'm sorry. Without the calcium to bind to actin, we cannot form the cross bridge, right? And what is rigor mortis? Rigor mortis is a lack of ATP, right? We got to go back and think. Remember, for actin to work, it needs calcium. For myosin to work, it needs ATP. So if actin and myosin don't have their resources, we can't have muscle contraction. And in the case of rigor mortis, that's something that happens after death where your muscles get stiff, right? And the reason why that happens is because after you pass, your body stops making ATP, and you need that ATP energy for myosin to unhook itself from actin. But without that ATP, the myosin stays hooked, and then the body remains stiff several hours after death. So again, be familiar with the steps of muscle contraction. Be familiar with that order. That's going to take you a long way.